Hi, today we're going to be going over the workflow of setting up an OpenRoads project file for alignment creation in IHSDM. The importance of this is to coordinate with the roadway teams as they transition over from inroads over to OpenRoads. This will make it much easier to coordinate together with them. So for this, project specific will set their own workspaces, but for our purposes in traffic, we're only probably ever going to use just this basic training Imperial workspace. We won't ever need to do anything more than that. It's simply just for annotation standards and different line work styles, but we'll never need to submit that information, so we can just do the basic setup. So we're going to do a new file. We're going to select our project location first. Let me just find a spot where we can save this. 7, 8, okay. So we're going to just call it Adam's tutorial. There's going to be nothing in it to start, and then we're going to attach everything that we need, and I'm just going to explain the basic file structure of OpenRoads. So I guess while we're waiting for that to load, we're going to come in here and look at the file structure of this project. So this is an Indiana project. So here's all of their OpenRoads files. So every design is its own DGN file. So their proposed pavement has its own DGN file. Their alignments have their own DGN file. Line work has its own DGN file. Topos have their own DGN file. Other inroads things, surfaces have their own DGN profile, existing and proposed. They have corridor surface DGN files, and they have all of their corridor modeling files as their own separate DGN. So here we are back in OpenRoads. We've just got a blank workspace. Nothing's in here yet. We haven't done anything. So what we're going to want to do is we're going to start wanting to reference in some of these project files that they've been using. So we're going to go ahead and we're going to attach a pavement file. So you can see I've got topo line work and proposed line work, both of which we want to be attached. These are also both in the Indie project folder. So we're going to just want to do a nice open here. We're going to coincident world, it'll align it. Live nesting isn't super important because we've got a nesting depth of 0, but you can leave it on for now. That just means it'll show other important references. Again, it's not super important that we have that on. Sorry, not super important that we have it turned off. So again, here's our second reference. We're just going to click OK. And now that they're both referenced in, we can come here and click on our fit to view, and you can see that we have our existing topo file as well as a proposed line work file, and then you can just click one of the, you can click off the topo line work. Now we just have the proposed build line work, and then vice versa. If you want, you can click off the reference here, and now you just have the existing topo. So the next step that we want to do to set up our model is we want to import their surface models, which give us the vertical elevations of this project. So I might have to dig around for a little bit just to see where they've got it stored. I think it's going to be in the Indie folder. So it's going to be Oh, here we go right here. TRN existing. So in OpenRoads, instead of surfaces, it's called terrain. Um, I'm just going based off their naming. EX typically means existing, so let's hope that that is what that is. All right, so we're gonna head and click open, and um, it might take a little bit to load this. I'm not sure how much information is in it, so it might take a second just to load up here. Just a quick buzz over some other stuff here. Other benefits of OpenRoads: it's easier to create drawing productions, so creating cross sections and plan sheets is supposed to be significantly easier in OpenRoads. I have not done anything with that or seen any tutorials, but word has it that it's much easier to do that. I'm just trying to go through what some of these types might be, just so you guys get an understanding as well. Scratch files, probably not much in there. Existing barrier, so that's probably a roadway barrier mapped out in a DGN. ALG, these are probably all the proposed alignments. Okay, all right, here we're back with the surface import. So it looks like the terrain was imported. So yep, you can see we got all these break line triangles, and now that blue dashed line is the outside of yeah, I guess it's just the outside barrier. So another thing we want to do is we want to make sure we set this terrain active, so everything we use will be using it. So we just hover over that border line and come over here to set as active terrain model. So now this is going to be it's going to be active. So whenever we draw an alignment and cut a vertical profile, we'll be able to see the vertical profile along a certain line, which we will do in part 2. So one last thing I'm going to show. So this is realistically all we will need. We'll only need these 3 files. The existing pavement, proposed pavement, and the existing terrain are really the only 3 reference files that we're going to need. However, we can also import geometry from ALGs. So in this instance, I did most of this project work originally in InRoads. So we have all these ALG files here. So I'm just going to go ahead and import this ALG file in here just so you can see what happens. So it says default. Now you can see all the alignments that I had stored in this. You can see all the alignments I had stored in here. So if we just click, it'll select all of them. And I believe we can set a feature, yep, right from this. So we're going to just set them all as geometry baseline so that it'll know that these are all alignments. And then if we click import, it'll bring in all of these alignments and associated vertical profiles. So here we have the 64 mainline build. You can see all the curvature. I guess it's not great. Okay, so you can see all the curvature and so on and so forth, and it's very easy to modify these alignments. So this is 5750. For example, if I wanted to make it bigger, you could just type in 7,000 and everything else is going to automatically recalculate, and it's very very handy. So we control Z that, but now we have everything we need to continue creating alignments for export in IHSDM. So I hope this was helpful. And again, if you want to save out this file, I would call this one probably proposed alignments or build alignments. So then you just do a file save as, but I'm just going to do a file save because I've already called it Adam's tutorial. So come back for part two of creating horizontal alignments and associated vertical profiles, and then exporting them for use in IHSDM.